A dynamite blast shoots a rock straight up into the air. Its height at any given time is x of t is equal to 160t minus 16t squared feet after t seconds. There are four things we're going to look for. A, how high does the rock travel? B, what is the velocity and speed of the rock when it is 256 feet above the ground? C, what is the acceleration at any time t? And D, when does the rock hit the ground? We're going to start with part A. So the thought here is that the rock reaches its peak when the velocity is equal to 0. Then we can find a position at that time. So in order to find the velocity, I start with my position formula. X of t is equal to 160t minus 16t squared. And we find the derivative, which is 160 minus 32t. We solve for 0, and we find out it reaches its peak, its maximum, when t is equal to 5 seconds. So knowing that, I can go back up here into this original equation, and I replace t with 5, and we get 400 feet. So the peak is going to be 400 feet. So the rock shoots up in the air, 400 feet, and then comes back down again. So the peak up here is 400 feet. Let's continue. Now we want to find two things. What is the velocity and the speed of the rock when it is 256 feet above the ground? Okay, so we start off with the position. Okay, x of t has to be equal to 256 feet. So I take up here, our original, 160t minus 16t squared is equal to 256t. Or 256 feet. Sorry about that. I did not mean to say t. This is a quadratic, so I'm not going to take the time to solve that. If you need to review solving quadratics, you can pause the video and work that out. But when we solve that, we find out that happens at two spots. The rock will be on its way up, will be 256 feet above the ground at 2 seconds, and on its way back down, it'll also be 256 feet at 8 seconds. The velocity at those two times will be 96 feet. And we get that by going up here and plugging into the 2 and 8 into the velocity formula. Now notice the velocity on the way down is negative, right? Because it's on the way down. Velocity has a direction to it. The speed is the absolute value of the velocity. So, because speed doesn't have direction, so it's just how fast it's going. So the speed is 96 feet per second. Now let's turn our attention to part C. For part C, we want to know the acceleration at any time t. So to do that, we want to find the second derivative of 160t minus 16t squared, or we could go back to our velocity and take the first derivative of that. Both of those will work. When we differentiate those, we have a of t is equal to negative 32 feet per second squared. Now we want to know when the rock hits the ground. Okay, the rock is going to hit the ground when the ground is at 0. So we solve for 0. This is a quadratic, so we're going to get two values. It's going to be at the ground at t equals 0, which makes sense because before the rock blasts on the ground, it's at ground level. But then it's going to hit the ground again at 10 seconds because the rock is going to travel up 400 feet and come back down. So the rock is going to hit the ground when t is equal to 10 seconds.